This is why we're doing the dissolution testing apparatus in the back. This is why we manufacture it, to provide this for a customer. Purpose of the test is to predict the bioavailability of a product, check the robustness of the dosage form, check the sensitivity to the variations of the manufacturing process which have critical influence on the dosage form performance, quality control to ensure the uniformity of the product within one batch or among various batches and from instrument to instrument. The history of it is we basically didn't have a lot of oversight on it until the 1970s here in the United States. In the USP 18, they called for the use of a 40 mesh cylindrical basket, make sure that the vessel itself is cylindrical, concave bottom, 1,000 milliliters, 1 liter. For tablets and capsules, originally there were only 6 monographs required. In the mid-1970s, the scientists recognized the problem of variability within the dissolution results from one apparatus to another. USP and FDA, both United States agencies, pushed for standardization of dissolution testing. In 1977, the FDA publishes the need for bioequivalency testing. In 78, the FDA published the guidelines for dissolution testing in the pharmaceutical technology. Proposed changes to the dissolution general chapter was for apparatus 1, the basket. The vessel needed to be cylindrical, hemispherical bottom, 1,000 milliliters. Gold coating of the baskets to, let's see what that, 1/10,000th of an inch. Apparatus 2 was a paddle blade, dimensions are given within the USP. Coating with the suitable fluorocarbon polymer, wire glass helix may be attached to the floating dosage unit. And again, I'm just going over the history so you understand why we're doing the testing. In 79, it came up with the suitability test, the performance verification test. USB dissolution calibrator, disintegrating type. Originally there was a prednisone tablet that was designed for it, along with a salicylic acid. The prednisone is a disintegrating type tablet. That's what was one test that was performed. Salicylic acid was a non-disintegrating tablet that was performed in a buffer solution. The acceptance table prior to this, that's when they first came up with an actual acceptance table with chemical testing. Before that, it was just a 75%. Was the default passing required for a number of units tested. In 1980, the USB chapter numbering became into effect. 701, which deals with us, and 711. In 1985, they defined it even greater to include both the apparatus 1 and 2, along with other types of devices that can be attached to each one of the shafts. Because we went from 1, 2 to 3 and 4 at that time, to USB number 5 and 6, to eventually number 7. In 2006, the harmonization between USP, European, and Japanese pharmacopoeias came into existence. Basically said that, oh, huh? I don't know if you need something.
No. Okay. We have to call back later, okay? Because it's not in yet.
Thank you.
Harmonization between United States, European, and Japanese pharmacopoeias.
Yes, that's right.
As outlined in USB 29, 711 dissolution, and talked about the basket apparatus 2 for the paddles, 3 for the cylinder, 4 for the flow-through cells. 2.93 dissolution test for solid dosage forms was included. The Japanese processes and apparatuses is a 6.10 dissolution test. Again, all the world regions started coming together and started getting on the same page as far as qualifications go. I'm not sure where everybody's from in the world, but I'm touching upon. We hear, when I'm training here, talk about a lot of the United States methods, but since 2006, they've pretty much become interchangeable. Most countries are adhering to the same exact standards. The solution assesses the performance of drug products. To be effective, the test should be predictive, comparative, discriminatory, and reproducible. The solution testing is comparative, from formulation to formulation, from a fresh product to an aged product, from batch to batch, and from the old process to a new process. It should be throw this in here so you can see where it actually talks about in 711, where it says the general chapter is harmonized with all the other agencies in the world. And we get to where we do dissolution testing. The equipment must meet the physical requirements given to USP General Chapter 711. 711 outlines the measurements of everything to the nth degree. Talks about what the vessel measurements can be. Talks about what the shaft can be, the verticality. Talks about how everything has to be set up. Talks about what the actual measurements of each one of the paddle bays has to be and what the basket can be. Gives exact measurements for all of this stuff. Distek, when we sell our units, we sell them with our certificates that already state that those have already been measured. The only thing we're required to do once it gets out into the field is now measure it on the device and make sure it's delivered as it was manufactured here. It operates the same way as when it was manufactured here. It adheres to any QC testing that was performed here on site. And that when we go out and do our periodic, here we recommend every 6 months doing the qualification tests on it once again, and make sure that it adheres to that every 6 months, that it's still within the accepted specifications. Right here we talk about it provides the dimensional information that can be used for DQ, IQ, and OQ vessel dimensions and stirring element dimensions. As I was stating, the DQ, which is the design qualification, includes all user requirement specifications, defines clear, concise, and testable requirements. The IQ, the installation qualification, again, verification of the environment and the acceptability of the unit as received on site. So once it gets someplace, it still operates the same exact way as it did when it left Distek. The OQ or the MQ is the evaluation of dimensionals and functional conformance to specifications, i.e. the mechanical calibration, and the performance qualification, which is the performance verification testing, conforms to the acceptable operation of the equipment, USP performance verification test. And the best practices. We're going to get into a lot more in detail when we start doing hands-on on the unit. I'm actually going to bring a set of hand tools in here and we'll go over how you use them and the measurements that you're looking to find for the specifications. I'm going to go over some of the things that are not covered on using those actual hand tools, and that would be visual inspection. The purpose of visual inspection is to ensure that the apparatus, which is one part of the dissolution system, is in good condition, meaning the unit itself. When you come up to a unit to do a qualification on it, a visual inspection to make sure that everything is normal. Usually turn on the unit, make sure that everything powers up as normal, as indicated. It's in our documents that way also. Just, an observation of the environmental conditions. Make sure there's not a lot of acidics being spilled on the unit. Make sure there's not a lot of other things that may cause problems down the road. You find that a lot of times when things drip in a laboratory and fall into the nooks and crannies, it can affect the electronics of the unit. In particular, the symphony that we have. Because of the way that it's designed, a lot of customers like to spray water on the shafts in order to clean it in between runs. And if you're not paying attention to the cracks in the back of it, you can spray water inside and start damaging some of the electronic components within the symphony. So again, environmental conditions need to be adhered to, the general cleanliness of the unit, of the laboratory. Normally, if I go in someplace and I find that there's a lot of spillage on the unit, a lot of issues with the unit, maybe they've had some mechanical and or electronic issues with the unit because of some spraying of the water on it, I'll do the cleaning, I'll do the repairing of the unit, and I'll also instruct the customer the best practices to employ when using the instrument. Our water baths that we'll also look at back there, you need to check the baths for leaks, the tubing, the joints on the unit, the bath itself, any connections. On the circulation pump, check for leaks, trapped air, noise. Good practice to change water regularly, use clean and clear water, and use some kind of fungicide or algicide in order to prevent the buildup inside of it. Shafts and baskets, careful observation of the physical condition is important. It's in there, we do check shaft verticality, we check the shafts. But on removable shafts, on systems that have like the 2100s that you guys are inquiring about, that have removable shafts, it's always nice to make sure they're stored in a proper fashion, to not nick and scratch them. You need to try to alert your customers to the fact that that can be something that can happen, and to make sure that they're not throwing them around, causing bends in them, breaks. There's all kinds of things that can happen to them. Shafts for both apparatus must be straight. Shaft straightness is a both IQ function and an OQ MQ. In the IQ, we want them delivered nice and straight when they first get to a job site, a customer's location, I should say, and then during the OQ MQ function, they need to remain straight. We do check that, hence the shaft verticality testing. As an IQ, it confirms acceptability on receipt. As an OQ/MQ, serves to measure the contribution of the shaft to total wobble. Because anything that happens with the shaft, if it gets bent in, for instance, the bass that we're going to work on the back there. Any time a vessel's taken out of it, sometimes people catch the paddle blade or the basket shaft. They catch the shaft as they're removing the vessel out of there. That pulls on the shaft. Several times of pulling on that shaft can eventually end up bending the shaft to where it's going to start producing a wobble on the unit. And I don't know how many people are doing performance verification tests using the calibrator tablets, but that can impact a passing or a failing result to a great degree. Any kind of wobble that's inserted into the unit. So something to look out for. Loose basket adapters will cause wobble. The O-ring that's around the basket adapters is not changed out regularly. That tends to get worn from putting a basket on and off the basket adapters that we have on our units. If that's not changed out on a regular basis or paid attention to, that can cause the source of a wobble within the unit. Baskets should be right cylinders, not bent. They should look like little cylinders. They should not be offset one from the other. Baskets have a tendency to get bent when thrown into a drawer with a lot of other apparatus. So something to look out for when you're working on these types of instruments. Baskets that are old, distorted, and frayed can give non-reproducible results. Baskets should be properly cleaned and stored, ideally. And these are all just helpful advice that you may want to pass out to the customers after you're working on the units. And the vessels. A lot of people overlook the vessels. Nicks, scratches, all these things that are on there you can check for, but basically the cleanliness of the vessel. Any kind of sticky product that's left to dry on the vessel, dries on the vessel. And then as soon as you start doing another chemical test, can interfere with the results and cause some cross-contamination issues. It being sticky can add resistance to the overall hydroponics of the media that's swirling around inside each one of the vessels. So the cleanliness of each one of the vessels needs to be paid attention to. Along with the scratches. I can take a vessel and pour some baking soda inside of it and rub it around on the bottom and lift it up to this light, and you'll see nothing but scratches in the bottom of it on ones that are scratched. Each one of those scratches that are inside there is causing extra hydroponics to happen within the unit that's not what we built into the unit. So paying attention to glass, to scratches, to nicks. People drop basket adapters, people drop paddle blades themselves into the bottom of the basket when it's not being used. Every time that happens, that can potential for causing a scratch and or a nick that could impact any kind of testing. That can happen at any given time. So paying attention to these things is key and essential. It's also something to look out for whenever you're doing chemical testing. If you're doing a chemical test and you're having failing results, that could be one of the reasons why you're having a failing result. So that's an out of tolerance item to look for. Always check the internal surface of the vessel on receipt before placing them into use, especially when you're getting a brand new unit from us, delivered overseas. If you're getting the unit, make sure the glass is not nicked, scratched in any way, shape, or form. It shouldn't be. An ideal world, everything should be shipped properly, but we know, and I'm sure you've seen things get shipped, and they're broken upon receipt. But it's just one of the things you need to check out for. Irregular curvature can affect hydroponics, the hydrodynamics of a unit. Older glassware. Some laboratories employ a lot of older glassware. Older glassware wasn't manufactured to the same specifications as today's glassware is. Today's glassware is they've kind of got it down to a science nowadays, but a decade ago, some of the older glassware didn't necessarily adhere to the exact specifications that's written inside the USB. I've taken several vessels and shown them to customers, placing them upside down on a desk, and you can see the curvature of each one of them was a little bit different from each one of them. They need to all be the same. I prefer using them all from the same manufacturer. I've been to a customer site before, and they've had 5 different vessels on an instrument. They've had one of ours, maybe 2 Sun vessels, maybe another one from SLA, QLA, maybe another one from Varian. They'll use any kind of glassware they can find in the lab, and unfortunately, every one of them had a different curvature to the glassware. So every one of them was giving me not a true result. So during my chemical testing, when I had a failure, one of the first things I said, let me try it with all 6 like vessels, and that actually corrected the problem. I had a passing result the next time that I ran it. So paying attention to the glassware, the buildup of residue, scratches, nicks, anything of that nature is key and essential in doing the testing. We're going to go over each one of these when I talk about the hand tools. So we'll go into those in depth. The height, shaft wobble, vessel and shaft verticality, the temperature, centering, shaft rotation speed. And we'll actually do that on each one of the instruments, so I'm not going to go into it in depth right now. But those will all be covered when I go through the validation presentation. But vibration is a key thing. USB specification is kind of ambiguous. They don't define it very well. They talk about this is exactly out of their document, and it says no part of the assembly, including the environment in which the assembly is placed, contributes significant motion, agitation, or vibration beyond that due to the smoothly rotating stirring element. Doesn't tell you any quantitative measurement. We've defined it here at Distek from a document written by Dr. Hansen to be 0.01 mils. That's not necessarily exactly what anybody else in the world is going to adhere to. I don't know if you have specific guidelines that guide what you're measuring your wide vibration at, or if you just simply piggyback off what we've already written. But it's a key thing, because in a lot of laboratories that I've been to, vibration can be an issue when it comes to performance verification testing, the calibrated tablets. We've had issues with laboratory environment, with air conditioning units kicking on and off, causing some significant vibration. We've had, in a manufacturing facility, trucks moving around, hand trucks going around, pallets being lifted, causing vibration in the instrument as it's being ran. It's only a 30-minute test, but it can significantly impact the qualifications that we're trying to perform. So you need to pay very close attention to the type of vibration that you're getting. Source of vibration can be on the unit itself. It can be tension or dirt on the drive belt or the chain, worn parts on older units especially, old gears that the belts are running around on, old belts. Build up on each one of the gears as the belt's going around can cause a vibration. You can pick up most of that by simply putting your hand on the unit and feeling. 2 best tools you ever have in your tool bag is your eyes and your hands. Being able to observe something that's happening on the unit, being able to feel something that's happening on the unit. That's the 2 biggest tools you're going to ever have and use on anything you work on. Alignment of the belt guide plates, surging of individual spindles, those are all things to look for in trying to determine a source of vibration that may or may not be causing you some failures. And then the environment. Turbulence in the water bath, an unstable, which could be caused by a TCS not functioning properly, a circulator. An unstable bench top or table, could be something else on the table. Could be a sonicator at the end of the table that's coming on and off that you just didn't catch when you started doing your test, but in the middle of your chemical testing, somebody's using a sonicator that's on the same bench that your apparatus is on, causing a significant vibration. Centrifuges, fume hoods, vacuum pumps. There could be construction going on in the room next door. That's happened to me personally before. Didn't catch it. It was on the floor above me. Never knew what was going on. Everything went fine during my entire testing, my physical portion of the testing. When it came to the chemical test, suddenly stuff started happening that was causing all kinds of vibration inside the building. So these are all things to look for in trying to determine what may or may not cause problems or failures to the testing process. And again, we're doing this testing because we want the customer to have a good unit in order to perform their testing on it. So it doesn't do them any good if we pass all our tests, but then they get sporadic results. They have results that are not reproducible. If they're not getting reproducible results, then their unit's not doing them any good. Then there's a problem with our product. The first thing they're going to do is say your product's no good, which we've been selling it everywhere. We've determined that it is good. So
What is the level of significant vibration that we can accept, or we say
Well,
this,
again-
this bench is not
001.
We've actually wrote that down, and we're measuring, it's 0.01 inches is what we measure on our devices. And we got that number from Dr. Hansen. I can actually bring in some of the documents that he has later on when we start talking about the validation tools. When we start talking about using the vibration meter, I'll show you guys exactly what he wrote. But again, he determined that. Now, where did he come up with that quantitative result? I have no idea. I've been doing this for 15 years. Nobody's told me what the actual vibration should be. However, having done it for 15 years, you get a kind of a feel for what's going to work and what's not going to work. I've seen a lot of different things happen with the chemical testing. Spikes. I've had my vibration meter sitting up on a bench. In fact, we have a place up in New Jersey right now that they built a brand new lab, and they're installing all their equipment on the 4th floor of this laboratory, this building they manufactured. And everything is out of specifications for the vibration. There's not one place in that particular floor that I can measure and not having out of specification vibration. However, since there's no quantitative number written by USP, I can't tell them that's an invalid way to run their laboratory. I could recommend that may have an adverse effect to when I start doing my chemical testing. So that gives me a way out. So when I start doing my chemical testing, if it doesn't pass, I can point to the vibration and say that's what caused it. I ran my chemical test and they passed, okay, which was surprising, but it passed. And then it passed on the next one that we installed. So I'm going to go with the idea that I was getting spikes that were going up and out of limitations. Again, as I said before, 0.01 is the specification. I'm sorry, 0.1 inches, tenth of an inch, but I was getting 0.08 in that neighborhood, which is close to the limitation. On a normal measurement, I was measuring it, I was getting like 0.07, 0.08, and it was spiking up above that. I was getting up above 0.1, I was getting 0.14, 0.15, 0.18, but it was spikes that were going above it and then coming back down below it. So I'm going to say if it was happening all the time above the specification, probably is not a good thing, because I was getting spikes that were going above and below it. It didn't affect my testing. My testing passed. So I would love to answer that question for you. Even USP doesn't answer it. They leave it very ambiguous. And again, I haven't seen anybody in the world other than Dr. Hansen actually address the vibration issue, causing, putting a number to it. So that's the number we went with, and we've had it in our documents since I've been here at Distek. It's worked till now, and I'm going to hope that it's going to continue working into the future.
I mean, is it enough just to put some water in the vessels and see if it is moving?
True. That's a very good. We actually use a vibration meter for a quantitative, but you could, by all means, to the visual eye. Basically, if you put your hand on something and you can feel it, you can feel whether there's a vibration in something. I don't need a vibration meter to show me that there's a vibration in the back. I can put my hand on the unit and I can feel whether there's a hum or a little bit of a vibration going on. We all can.
But you have a requirement to write an exact number in the IQ.
Yeah, we did.
OQs.
Well, we're discussing whether we want to take that out
So we are
in future documents.
we are pressed to use your vibro check.
Yes.
$3,000.
Just say that topic.
We don't manufacture it. We purchase it from an outside vendor and resell it. But yeah, I understand what you're saying, and that's duly noted. As a matter of fact, I'm involved in writing the documents, so it is also something that's in heavy discussion right now on whether or not we want to take that out of our document. There's a couple things we want to take out and leave it to, if USB can be ambiguous with some of their writing, such as the vibration, maybe perhaps we can be too. Maybe not as tight as it is. For instance, we've had several discussions as far as the centering of the unit and what USB says and what we have down in our document. Our document's a little bit tighter. Same thing with wobble. Specification in USP right now talks about the wobble needs to be 0.039 inches, and we've made it 0.010 is our limitation. As a manufacturer, we've always felt we could keep it to a tighter specification. However, that maybe we need to come off of that, maybe think about maybe not making it 4 times as tight as USP is calling for. So we've had some discussions here amongst us, and we're thinking about altering some of our documents in the future. We'll have to show justification as to why. The customers, because customers, once they something becomes an accepted practice, they're very reluctant to have it come off of that accepted practice. But we'll see what happens going forward.
I can give you a phone number of this Sasha from Teva,
Yes?
and you can ask him about this vibration and wobble.
Yeah?
Because they are making, if specification, the best is like this, it must be even better.
Yep.
And
I
he
know.
knows everything from dissolutions till balances, HPLC, so.
Well, but I mean, again, the argument can be made as far as, you know, like I said, USB specification on that is .039 inches. We've made it .010, which is almost 4 times tighter than what USB is calling for. I'm not saying roll it back to .039, but maybe we could come off the wobble and make the wobble .020 as the specification. Maybe only twice as, because again, I don't know how many of you are making the measurements. I'm assuming all of you are. Maybe you're not all doing it, but I found in my travels, some of the measurements, sometimes my wobble's a little bit off. It's a very tight specification to here. Not on brand new units, not so much, but on legacy equipment. Try and find an old 2100, as you're talking about working on 2100s, with some old shafts that are fine with the wobble. It's most of them you'll find sitting at .08, .09, or .008, .009 inches, coming close to the limitation that we've set, which is .010. So it's hard to keep some of the older equipment within that specification. The older it gets, the more worn out it becomes, the more you have to continue changing. And I mean, I guess there could be an argument made for that, well, then change the parts out and make it a little bit tighter so that it's passing the chemical test as it should be. If we can make it the limitation at .020 and still have our chemical test passed, then I don't see no reason why we can't go to that particular formula.
I don't think this will be helpful because wobble issues are 100% improper use from the end user. They pull at the baskets.
Oh, I know. How they pull the baskets off, pulling a vessel out. They'll pull a vessel out and they'll catch it as they're,
And this is the easiest way to set up the wobbles with your finger. So.
Yeah. That or bending it back, but you know, how many times you're gonna, if you took a straight shaft and you bent it here one time and bent it back, and then bent it down here a little one time and bent it back, at the end of the day, you're gonna have a nice wobble to the entire shaft. And eventually the shaft ends up having to be replaced at some point, but you know, there's arguments for both sides of this. We can keep on debating it all day, but it's just, again, at the end of the day, it's just, there's something to be said for maybe changing some of our specifications around.
But this will not help. They will continue use it improper.
Oh, that's them. Us changing the specification doesn't change what the end users want to do. They you know, for such an expensive device as the dissolution bath, it's amazing that you know a lot of the customers treat it worse than they would treat anything else that they've ever owned. But it happens. We all know. We've all been in the laboratories and seen how people treat the instruments that they work on. And of course, it's our fault when it doesn't work right. So we want it fixed tomorrow. But anyways, any other questions? As far as the qualifications go? No, all right. Talk about some of our bass this time.